Hi, this is Matt at Parallax. I wanted to give you a quick tour of one of our newest cool products. We have the BlocklyProp Starter Kit, and this is designed to work with our new Blockly system. The BlocklyProp Starter Kit is a cool assortment of sensors, of inputs, of outputs, and it comes in a really cool box. It's got all kinds of fun stuff in there. So if you go to our website, parallax.com, and you'll see the banner here, or you can actually scroll down to kits, and inside of our kits, it's right here at the end, the BlocklyProp Starter Kit. This is everything you get in the box. A really good selection. Like this is our color sensor. This is our ultrasonic distance sensor. We've got a cool OLED screen. We actually have a TV remote in there, which makes actually a great input. We've got a standard servo. Basically everything you need to get started to kind of power your inventions. And so you end up with cool stuff like where you can take the ultrasonic distance sensor and display its output on a screen. Blockly is our new graphical-based programming system. So Blockly is actually something that Google came up with a few years ago, and it's in the same family as other graphical programming languages such as Scratch that was developed by MIT or Snap. Blockly is kind of unique in that it was designed for other people or other entities or companies such as us to use. And so Blockly was sort of created as a tool which then allows other entities like Parallax, for instance, for the Propeller. We could use Blockly to create the C language that we can then upload to the Propeller to do the things we want it to do. And so this is our branch of Blockly. It's on the system, so all you have to do is go to blockly.parallax.com. In fact, when you do that, like for instance, if you just type in blockly.parallax.com, it'll add this little bit in here, and you'll see this web page. So this is the first page you get to. When you're here, you're going to need to become a new user, so you'll click Login Register, and it'll ask you to log in. I've already got an account. Otherwise, what you do is you go over here to Register Now to create an account, and it's just like creating an account on any other website. You give it a username and a password. It'll send you an email to just verify that your computer is who you say it is. And then from there, once you've got an account, you log in, and then you start seeing that you've got your username up here. And right now I've got my window kind of shrunk, which is why that top bar looks that way. And so I shrink that back up so that we can see kind of what we're doing over here. So this is where we'll build things with Blockly, and then here we'll program them. So there's a few things on the site here right off the bat. We've kind of got the banner here. We also have community projects. So if you can go in, you can see what other people have done in Blockly. You can go to your own project. So right here, I've got one project in my account. And then also, if you're doing a new project, there are two sort of systems that we have under Blockly. One of them is for our S3 or Scribbler robot. And so you can do a Scribbler robot project, but today we're going to focus on the Propeller C. So the Propeller C is what our BlocklyProp Starter Kit and the activity board use. So when you click on this, if you're going to do a new project, here you'll click there, you'll type in a name for your project. And so what we'll do is we'll start with just kind of your basic HelloWorld, which is a great way to just get started. We're going to dive right in because I want to demonstrate just how easy it is to get a program completely off the ground from literally scratch. So you type in Hello World. We're going to say that our board type is the Propeller board activity board WX because that's what comes in the starter kit. In the description, you don't have to type anything here. I'm just going to type hi. I'm also going to share this project just if anybody wants to come back in, they can see if I click shared here. It'll show up in the community projects once I'm finished with it. So I click on finish, and now what I've got is I've got a whole screen here in front of me. There is something else that you need, and if you're not using this for the first time, you might see red text up here instead. And what that red text is going to say is BlocklyProp Client not available. Now the BlocklyProp Client is a piece of software that you're first going to have to download. Once I've started that up, it shows up here, and there's going to be a small window here. And what this is it allows us to connect the servers where Blockly is compiled. So Blockly you'll have your computer. Let me see if I can draw a computer for you. And then you're going to connect your activity board to it. So this is the board that you're programming. And then up here in the cloud, everybody's kind of heard of the infamous cloud. BlocklyProp is a system within the cloud. So we've got the BlocklyProp server here. And this is my computer. So what you do is the BlocklyProp Client, when you install that little piece of software on your computer, see if I can draw that logo here. When you install that piece of software on your computer, what it does is that becomes the link that allows your computer to communicate with the cloud, because the cloud is going to contain a piece of software that does the compiling for you. So it hosts the web page. So when you go to BlocklyProp, that's a web page. So when you say blockly.parallax.com, you type that in, it asks the cloud for the web page, the cloud sends it back. And on here, you create your program, and then when you say compile, you need the little BlocklyProp client on there to kind of do the communication, to make sure your computer knows how to connect the cloud to your activity board. So it's that missing piece in here. And so without that software, the cloud can't actually compile your software and make sure it gets sent out to your activity board correctly. So it's a necessary piece. In order to make that work, you go here, you click connect, and what it'll say is it'll start up the server, it configures itself, and then everything's started for you. So if this isn't happening, then it doesn't work for you here. Once you're here, this is the workspace for all your blocks. And what we'll do is we'll set this to the side and show you what's in the box. So this right here, zoom that way out here, this is the box. So what I'm going to do is I'm going to open that up and show you everything that's in it. There's a nice card to greet you. It says, hello, it's nice to meet you. It gives you a little information in case you're not quite sure where to go. There's actually a link to a tutorial here. So just for fun of it, show you what that's all about. So we have a site. If you go on our main website, or if you go to learn.parallax.com, under tutorials, you can go to language specific. Because BlocklyProp is a programming language, even though it's a graphical one. You'll go here, and we've got getting started with BlocklyProp for the activity board WX. And so this tutorial will walk you through everything that I'm kind of doing here. It tells you a little bit about it, tells you about how to set it up, what it is, kind of getting registered. So it's got a little more detailed information that I'm going to run through here in the video. But it's all right there. So it kind of talks about the interface. That's all available for you. If you ever get stuck, we actually have free tech support. There's information here on the card. And then on the back side, we actually have some really helpful reference information. So that right there contains like some information about resistors, power, capacitors, LEDs. Just in case you're using this in a classroom, this is just a great reference to have, or if you're just a hobbyist. It's just a nice, it's a nice graphic that's got a lot of helpful information on it. Kind of a bill of materials. So for classroom use, this is great because you can use this to check the kits back in, make sure that nothing got lost or broken. The other thing this lets you know too is kind of what's in this particular box, because we want to keep supplying this kit for a long time, but we also recognize that over time things like sensors get better. There might be something that hasn't even been invented yet that we might want to include in this kit. So we'll make sure that that's in there for you. And so every box will have a listing of what's inside the box. And then also some part numbers if you ever want to reorder or order additional. Or if, in a classroom, one hits the floor, a student walks over it, breaks it, and that, in reality, that does happen. So the part numbers are helpful in case you ever have to reorder something. Now the star of this kit is the Propeller Activity Board WX. And so this is in here. The other thing that it's actually going to say is it says stop install software first. You need to download USB drivers. When you download the BlocklyProp client, one of the pieces that comes with that is the drivers, or at least instructions on how to get there. And so that's a helpful thing for you to know, that there are some drivers that you're going to need on your computer in order to get it to talk to the activity board. So this is the Propeller activity board. Also inside of the bag, I've already put mine on here, but you're going to find a set of rubber feet to attach to it. Mine are already stuck on, but those are helpful for a couple reasons. One, all these little pins that come through the bottom here, if you were to set this on a metal desk, for instance, you could short things, and so it's always helpful to set it on something non-conducting. like a piece of paper or wood or Formica desk. And also the rubber feet are kind of nice because then nothing slides around on you. There's also some other stuff in the kit, like we have a bag of goodies and just some general electronic parts like LEDs, capacitors, jumper wires. There's a header for connecting a servo to the breadboard, resistors. There's also all kinds of stuff. Push buttons. There's this actually is this little sticker on top of a piezo speaker. We're going to play with that here in a little bit. There's a 7-segment display. Bigger capacitors, smaller ones, LEDs, connecting wires. So all kinds of good stuff that we're going to need here in a little bit. There's a battery pack. This is actually an infrared detector that goes with the remote. A standard servo and some 3-pin cables that are good for connecting these headers to a few different sensors that we have. There's a box, and in the box is a universal remote. And there you go. So this is just a standard kind of universal TV remote. There are you do have to program this much like you would if you were programming it for your TV at home, but we've got instructions on the help to do that. The USB cable, this is important. So that'll get plugged into the USB port here on my computer. I'm ready for it. It's plugged into the board. Right now I've got my switch set to the off position, but when I turn that on, you can see one light comes on. The second power, so the 2 position, actually powers up these headers up here. These don't receive any power when the switch is in the 1 or off position. The power that goes to these headers won't come from the USB port. So the USB port, even though the switch is in the 2 position, won't send any power to these headers. In order to do that, you actually need to use the battery pack. And so if plugging in something like the servo, for instance, like this guy, if I wanted to plug this in up here, and it actually says ground, which is the black wire, so making sure that the black wire is kind of on the downside of that. So if I were to connect this up here, this wouldn't do me any good. It wouldn't work until you connect the battery pack to it. So if we wanted to power that up, plug some batteries into it. Now I've got batteries, and that goes in the barrel jack right here. That will allow the servo to be powered. We're actually going to turn that back off until we're ready, a little closer to ready for it. We'll leave the servo plugged in. It's not hurting anything. This is a small, it's called the MEMSIC Dual Axis Accelerometer. This is kind of a cool little sensor. Actually uses, inside of that little silver case, it uses heated nitrogen gas to tell, and then temperature sensors on either side, to tell if the sensor's tilted one direction or another. And so this is kind of a cool little thing because you can tell, well, like, hey, have I been tipped over? You can also actually hold it up like this, and we've got a block that lets you know you could use it like a steering wheel in addition to being, or instead of a tilt sensor. So lots of options there. We also have this PIR Mini Sensor, and what a PIR sensor is, this might look a little bit familiar to you, but if you've ever seen kind of a motion detector, an alarm system in your house, the PIR sensor is what they use as the motion detector. And so this little guy right here, when you plug it into the breadboard, if once it kind of gets a reading of the room and it's settled, if it detects any kind of motion in the room, it'll trigger. So it'll send a voltage out one of those pins. And you can use this as a motion detector for an alarm type system. We also have a ColorPal sensor. ColorPal is kind of an amazing sensor. This is actually a color detector. And so you can hold this over, for instance, different colored like paint chips, or you could even use it, for instance, as a candy sorter. So like if I had different colored chips here, this would actually be able to tell me, hey, I'm looking at something red, looking at something orange, something yellow, green. It's a fun little sensor to work with, and it's kind of amazing how that works. We also have a joystick that you can use. It takes up a lot of breadboard space, but it's kind of a fun way to interact with your microcontroller. We also have a ping sensor. This is an ultrasonic distance sensor, and so you can do a lot of different things with this, including you could use this to detect motion. You could use this to tell, hey, how far away is something? Is there something in front of me? Lots of options with this, and it works from anywhere from 1 inch to 10 feet away, and it works by echolocation, so it actually sends an ultrasonic chirp that it's so high frequency your ears aren't able to detect it. It sends it out, bounces off something, and the other side of it listens for it, and the amount of time that it takes for that chirp to come back is what this sensor uses to determine how far away something is. So it's surprisingly accurate. An RGB OLED display. So this right here is actually a small screen. You might have saw it on the cover of the box itself or on the banner on our website. But the OLED screen is kind of an amazing, fun little tool because you can do everything from draw shapes to write text to it. All kinds of cool stuff that we can do with this. So we'll set some of this stuff off to the side and we'll kind of build some things up as we go. We've got our activity board here. On the other side in our workspace, we're set up to do our HelloWorld program. Now I'm going to flip the switch to 1 here. And in our workspace, these are where all the blocks are, just off in the menu on the side here. So if we click on control, we can see kind of some basic control structures that you might find in programs or putting things inside repeat. If you're new to Blockly, this might look a little bit funny, but once you start dragging blocks out to your workspace and you start working with them, it's surprising how quickly you'll be able to grasp onto this. So we're going to go into communicate and communicate with the terminal. So we've got a few different options for communicating with things, including that OLED screen that I just pointed out, but the terminal is the computer itself. And so what we'll do is we'll drag a block out here that says terminal print text. I'm going to add hello world because it wouldn't be a hello world program without hello world. Then I'm going to say, and then a new line. And what this will do is it'll send text to the computer. I want it to print a number in addition to that. And so what we'll do instead of printing a number, I'm going to get rid of this little single value block here. So go to numbers, and I want it to print a random number between 1 and 100. Now this should, if we set this up correctly, it should send hello world to the screen, and then it should send a random number between 1 and 100. You'll notice there's this then a new line checkbox. So if you check this, what it does, it's basically like hitting the return key and going to the next line, just like in a word processor. So let's go ahead and set this up. Now there's a couple of menus here. The first one is this. If your board is plugged in and everything is installed correctly, on a Mac you're going to see this USB serial and kind of a bunch of numbers and letters like an identification. On Windows, it's going to appear as like COM1, COM2, COM4. You might have to do a little experimenting or unplug your board and see which one disappears in order to figure out which COM port your board shows up as, or your activity board shows up as once it's plugged into your computer. So we'll make sure our board is selected here. We want to make sure BlocklyProp Client is available. If it's not, you'll have to go back through those steps. And then we've got some run options. The first one is just compile. What that does is it sends your blocks up to the BlocklyProp server in the cloud and just makes sure that they go together correctly when it gets there. So this doesn't actually run it, it just tells you whether it thinks it's going to work or not. Most things that you can create with Blockly are going to compile. That's one of the advantages of a graphical programming language as opposed to a programming language that's text-based where you're typing things in. So one of the reasons why Blockly and graphical programming languages are so suddenly popular and really effective with kids is because it's really hard sometimes for a kid who's just new to typing to then go straight into programming. Because it's really, if you're using a text-based language like BASIC or JavaScript or Python, even the easiest languages have syntax. And so if you accidentally insert a character or miss a semicolon in some cases, your program just doesn't work. And sometimes those are really hard things for kids to find. Blockly is a lot more forgiving in that we take typing out of the equation. You still have to think your way through it and have to think about what's going to happen in order here. So it's first going to do this and then it's going to do the next thing. By taking typing out of the equation, it eliminates some of those silly errors that very quickly can frustrate students and kids, or first-time programmers for that matter. So what we're going to do is we're going to take our program, we're going to load it to RAM. You'll also notice there's load to EEPROM. These are two different kinds of memory on the Propeller chip. So if I point to the Propeller chip here, the Propeller chip has 32 kilobytes of RAM. And RAM means random access memory. And what that means is as soon as the power goes away or you hit the reset button, whatever was in RAM is gone. So when we load to RAM, it gets here and it'll stay there as long as the power is on. As soon as the power is on, it's gone. EEPROM is actually this little chip sitting right next to it. And so the first thing the Propeller does when you power it up is take whatever's in here and bring it into its own memory. And so when you load to EEPROM, what you're doing is you're sending your program to the board more permanently by saving it here. Because if you save it to EEPROM, the Propeller then, that's the first thing that it loads up when it runs. And so your program will survive a power outage or turning off and turning back on or hitting the reset button. So let's go ahead and just load to RAM since we just want to run this once and see what happens. When I click load to RAM, it tells me compile was successful, and there it is. It brought up the terminal, and it gives me some connection information, and then it says hello world, and the random number it chose from 1 to 100, it chose 80. So if I close that, just to make this a little bit cleaner, I want to show you something we encourage people to do is, because the terminal always starts with that connection information, we can clear it out. It'll show up for just a brief little blip and then clear it out, and then I'll put hello world and everything at the top, right where we want it. So load RAM again, just to make sure it gets there. So it's sending it to the cloud, it's coming back, getting loaded up. You saw the connection screen, and then the clear screen cleared it out. Now it says hello world, this time it picked the number 62. So now let's introduce a couple of control blocks. And so let's separate these out again. And one of the control blocks I have is repeat. So what I want to do is I want to repeat forever. I'm going to put my hello world and print number inside. I'm also going to check this then a new line at the end of the number because again, I want the number to type and then go down to the next line. I only need the clear screen at the beginning of my program before I start repeating. Now, here's the other thing that we need. If you go back into control, one of the things that you have is this pause block. We want to leave that 1,000 pauses can be measured in milliseconds, and so we want to leave this as 1,000 milliseconds, which is 1 second. And so what it's going to do is it's going to first clear the screen, and then inside of the repeat structure, or inside of the repeat block, it's going to print the text hello world, go to the next line, print a random number, go to the next line, wait 1 second, and then repeat that again. Print hello world, give me a random number, pause. Print hello world, give me a random number, pause. If we set this up correctly, this is what we should see. So we're going to click load RAM. Send that on there, it clears the connection screen. Every 1 second, you get a new hello world and a random number. So what's happening here is that this information, you can actually see this, let's see if I can bring this up close here. You can see this little red light, it's a little hard to see on the camera, blinking. But what that means is the Propeller is actually sending information back through. All right, I think I accidentally reset something by touching it by my pen there. So I click on close and close that out. And now that's our first program. Hello world, it's alive. It's just really cool to think about that information is actually coming from the Propeller. The Propeller is what's telling the computer hello world. Another thing that's kind of a really good introductory thing to do is blinking some lights. One of the cool things about the activity board, it's actually got a couple of LEDs right here. They're labeled P26 and P27. Oh, hard to see right there, P26, P27. What we're going to do is we're actually going to blink those two. And so let's go to pin states, and let's pick, after we print our stuff out, we're going to make pin 26. Now, high is sending positive voltage to it. Low is sending no voltage to it, so that would turn it off. Toggle means switch. So if you were high, go low. If you were low, go high. And so let's send toggle to it. And again, wait 1 second. And so each time around, it's going to either turn on or turn off. So let's go ahead and load that to RAM again. And here you can see it. Blinking, turning off. Blink on, blink off. Blink on, blink off. And it will do this forever until you either take the power away or reset it. So we'll close that. Close that again. All right. So that's our first program. Now, what I'm going to encourage you to do is make sure that you save often. So I'm going to click Save right now. And when you do that, it's going to say, hey, my project's been saved, and confirm. You also have the option to save as, so you could save a copy of your program. If you did a whole bunch of work, but you still like what you had before you did all that work to it, you could do save as, kind of say, hey, this is HelloWorld version 2. I do want to make sure you understand that you should definitely save very often. So every time you're about ready, a good habit to get into is every time you want to load it to the board, save it first. The reason I say that is because right now there are a couple of quirks with Blockly that make it really hard to tell if you've been timed out or logged out. So let's just say you were working on a Blockly project, you left your computer on, you went out to lunch, you were gone for an hour, you come back and nothing on your computer screen looks any different, but the system timed out and it's technically logged out. The problem is that there isn't really any good indication or way for you to know that happened. So you could still keep building on this, build on this, build on this, and then when you click save or try to run it, it gives you some errors, and the errors are kind of weird and cryptic. And so it's a good idea to make sure you save your work often, and if you're gone for a while, log out and come back to it. So you can always just, after you save, you can click on the little puzzle icon here in the corner, and it brings you back here. And then from there, you can actually tell, you can say, oh, I'm logged in, or it might actually say, log in register. That way I know I'm logged out. And so I'm going to log back in here. And so it's a good idea if you've been gone for a while and you're coming back to it, don't assume that it's logged in. Just go back to the beginning, make sure that you actually are before you start going back and creating some work again. So now that we did this, you can see my HelloWorld project shows up in the latest projects. It is a community project, and community projects are ordered first by name, but you can also order them by board. So again, we've got Scribble or Robot or Propeller activity boards. What I'm going to do is I'm going to do a new project. I'll do Propeller C again. This time what I want to do is I want to mix the servo and the ping sensor. So the servo connected right here, and I'm going to plug the ping sensor into it here on the board. So I'll select the Propeller activity board WX, and I'm going to say using both, type correctly, the ping and servo. Click next, and I'll make sure this project is shared. I'll click finish here. So now I have my blank workspace. So before I dive into this too much, I want to show you where the blocks are located. So the servo is pretty obvious. It says servo right here. We're using a standard servo. I know this because it says so. The other kind of servo is continuous rotation, and those are the kinds that don't stop. They go around and around and around. A standard servo has about 180-degree sweep from one side to the other. So we'll click standard servo, and if I look at this, I plugged it into P17. So we're going to need that little piece of information. So we'll say, hey, I'm connected to P17. I can go from 0 to 180 is the angles I can choose with this. And then the other thing is the ping is a sensor. So if you open up the sensor tab, you'll see all of our sensors here. And so this is the ping distance. Now, these blocks don't connect together, so we're going to have to do a little work here to figure out how to make this happen. Now, first things first, what if I don't know how to hook up the ping? I want to show you a couple of really cool tricks with Blockly that might be really helpful. The first is that for all the blocks, you can hover over them. And this might give you a little more detail about what the block is doing. So it says ping distance, gets distance measured in specified units, matched to the Propeller I/O pin. So, okay, that's slightly more helpful, but maybe it's not enough info to go off of. And so the next thing you can do is you can right click. Now on my screen, I'm zoomed out quite a ways so you can see more since I'm trying to do both, this over here and over here. The reason I'm saying that is because when I right click, it brings up the standard menu. This shouldn't happen for you if your zoom level is set to 100%. All you got to do is just click off to the side if it does though. And this is the block menu. So by right clicking, you get a block menu and you've got some options here. The first is duplicate. That's kind of handy because maybe you've set up a whole bunch of LED stuff, or you've used a block that has some kind of complicated setup and you want to use it again. Or even better, if you've got a whole bunch of stuff inside a repeat and you duplicate the repeat, it duplicates everything inside of it, which is kind of awesome. So sometimes if you're trying to create something with a lot of blocks, that duplicate comes in really handy. The next thing that you can do is, when you right click, is you can collapse the block. So some blocks, once you start plugging in a lot of information into them, start to take up a lot of space. Like for instance, I'll give you a really good example of this OLED, drawing a line on that. If I collapse that block, it makes it take up a lot less space. So you can use collapse block to maybe make your program a little bit more readable, or not take up so much room or run off the page, that sort of thing. I'll actually keep picking on this OLED block because it's quite helpful. You'll notice on this OLED block that it's got a whole bunch of places where I plug stuff into it. Right now, all of these plugging things in are set as external inputs because they're on the outside edge of the block. The other option is for them to be inline, like this. And so you can toggle between, like we've chosen what we want the default for most of the blocks to be. Some of them we've chosen inline because it kind of fits the nature of the block. But you can actually toggle between the two. So here's another fun fact. Because the OLED has nothing to do with my current project, but maybe I don't want to delete it for some reason, I can disable it. And if I disable it, it stays here, but it disappears in my program. So it's no longer part of my program. If I take and right click it yet again, I can re-enable it. I can reset these all back to the way that it was with external inputs, or I can delete it. Poof, there it goes, and anything that was attached to it. You'll notice that clicking in the blank area here gives you some options like clean up the blocks, puts them in nice in the corner for you. You can collapse all of your blocks by clicking here. You can expand all of your blocks. The last one is the most powerful though. So you kind of saw those are all your options with Blockly. This one is by far the most helpful because it says help. If you click on it, it's going to take you to a page that is just for how to use this block. So ping distance. Now I've got something really helpful. Like let's say I didn't know how to hook up the ping before. Now I have a diagram that shows me. So if I follow along here, I can kind of read. I can read and get more information about the block, and I can follow this hookup diagram. So it tells me, just like I explained before, the round trip echo, lots of helpful background information. So I'm going to do this. I'm going to hook this up just like the diagram shows. Yep, so far so good. I need a couple of wires. I'll even use the right colors. So I need a red one and a black one. The red one's connected to that pin right there, and then it goes over to the 5-volt header. The black wire goes from this one right here. Make sure you can see that okay. Over to ground here on the bottom of the board. And then the next thing we need is a resistor. And the color code that I'm looking for on the resistor is red, black, red. So I kind of go through my little baggies of resistors here till I find one of those. Now, in this particular case, I can use something else if I want, but I actually have the red, black, red. The ping actually sends out a 5-volt signal. The propeller is only a 3.3 volt device. And so what we're doing is we're using a resistor to make sure that that ping sensor isn't sending too much voltage to the propeller. And so when I connect this here, this one goes in this last port. And actually, I didn't realize this, but good force of habit, make sure your board's turned off before you start connecting things. You can turn it back on when you're done connecting things. And then I'm going to connect this to P15, so right there, just like the diagram shows. Now, there's no harm in connecting it to really any other set of these pins, as long as I've got my power connections right. Anywhere from P0 to P15 is an acceptable place to plug that in. They're all the nice thing about the propeller is that all pins are really general purpose input output. On the activity board itself, we send some of them specifically to different things, like the SD card, for instance, the EEPROM, because the propeller has 32 different pins to choose from. We use P0 through 15 here, and then 16 and 17 additionally up on the header over there as kind of the general purpose ones you get to play with. So now that our board's set up, I'll turn that back on. We'll flip back over to Blockly here. Since I turned my board off, it reset my menu, so we'll make sure our board is selected, and we'll tell it, hey, we connected our pin to our ping sensor to P15. So now with the ping sensor, I have something I can measure distance with. And so just for fun, what we'll do is we'll disable this servo block currently. So let me just click disable block. Now, let me go back and use the terminal, because the terminal is going to be able to print a number for me. And so it's going to tell me, you'll notice that this fits. The ping is going to give me a number back. And so it's going to tell me a distance in inches. And what I'll do is I'll click then a new line, and just to repeat, and I'm going to put that pause back in here. And the pause is important because you could send numbers to the terminal so fast that it doesn't do a good job of handling it. So it's good to put, especially if you're printing to the terminal, it's good to put some delays in here or some pauses to make sure that you don't flood the terminal with information. So we're going to choose a ½ second delay. And then let's go ahead and run this. And now it's sending information. It's saying there's something 5 inches away. If I put my hand, now I'm only 3, 2 inches away, 1 inch away. All right, so this thing appears to be measuring distance. Very cool. All right, so let's do this. Let's centimeters. Maybe that's something that's a little more useful. I'll back this up just a little bit further. And let's run it again. So let me click load RAM. This time I'm measuring in centimeters. Oh, it says 1816 with my hand way over there. And now I'm going all the way down to 543. Kind of looks like the lowest it'll go. So between 3 and 15 or 16. So let me write that down. 3 centimeters to 16 centimeters. Now, let me close that. Let's re-enable this servo block. Enable block. So, if I look at this, I can go from 0 to 180. Well, 160 times 10, write my 0 a little better there, or 16 times 10 is 160. That's close to 180. And 3 times 10, that's 30. That's 30 to 160. That's close enough to 0 to 180 to give me something that I can work with. So I've got to multiply whatever ping distance I get here by 10. Now, what we'll do is we're going to store this piece of information in a variable because we want to print it to the terminal and we want to send it. We want the servo to be able to use it. And so with the variables here, what I can do is there are 2 different variable blocks. This one is used to set a variable or to store information into a variable. This one is used to get it back out. And so this one appears to a block like a number. So we're going to need both of these. So we'll connect this here. And what this, let's go ahead and rename our variable to distance. All right, cool. And we'll put that in here so that when it repeats, it goes and collects what information from the ping first, and then we go ahead and use it. Now, we noticed that 3 to 16 isn't going to do us a lot of good. We want it to be from 30 to 160. And so let's back this up just a little bit. The next thing we're going to need is an operator. So an operator, we have string operators, which let us do things with text. And then we have number operators that let us do things with numbers. So this first one here is the arithmetic operator. That lets me do things like plus, minus, times, divide by, or get the remainder after division. And so we want times. So we want, and I'm going to steal this number here because we don't need it there. We want to put our value in instead. We're going to say 10 times the ping distance in centimeters. And we'll store that in here. Now, let's go back to variables and let's get, and since we created a distance one by going new variable, it's going to show up in our menu. So we can use distance, and we can use it again. Now, if I wanted to pick a different variable like item or rename it or do a new one, I could do that here. And so now, this should, if we set this up correctly, is going to turn our servo based on whatever our ping reads times 10. So let's go ahead and run that. All right. Oops, it didn't work. What am I doing wrong? Now, what I forgot to do is I forgot to turn my power switch to the 2 position. Now, that's important because that's what allows these headers up here where the servo is plugged into to be powered. So let's try this again. Oops, it looked like it reset. We'll try this. Try reloading it since I flipped that switch. Well, that looks promising. Oh, here we go. So as I bring my hand closer, it turns it one way, and when I bring it further away, it turns it the other. And remember, I still have that half-second delay in, so it's only updating every half second. So let's do this. Let's close this, and let's make it a little more responsive. Let's get rid of the pause. Let's get rid of the terminal too, since we saw that it worked. There we go. Now we're going to run the program. Oh, we're stuck. Oh, wait a minute. There we go. Okay. All right. So now we're using the distance from the ping sensor to drive where the servo should go. Now, here's what I think is happening. I think it's a little jittery because we might be sending that a little too fast. Servos actually only expect, I'm dancing here, servos only expect information every 20 milliseconds, and they actually get a little bit unhappy if you send it more often than that. And I think we're actually sending it too often. So we're going to put a delay back in there and see if we can't make this work just a little bit better. And instead of being a full second or even a half a second, which is kind of a big delay, we'll set this to 30, which is, you know what, 20. 20 is really what it should be for a servo. So let's go ahead and run that. Let's see if it runs a little more smoothly. Yep, there it is. Cool. All right. So there's just one more fun thing that you can do with this. And again, this is just basically taking blocks, connecting them up, having some fun with them, and seeing different things that you could do. For instance, maybe what you could do is you could have this unlock a, move my pen here. You could have this unlock a door as you approach it, is something that you might be able to do. Or you can use this as a Halloween prop where somebody starts walking closer and you can have it drop a spider down. All kinds of fun things that you could do with this particular application. So, cool. All right, so we're going to click Save on this, save our project. Now let's do another one. So we'll go ahead and go do a new project. So I'm going to click on New Project. I'm going to create a Propeller C1. So let's go ahead and type in my new project. This time I want to use the Color Pal and the OLED. So my board type is the Propeller Activity Board, WX. Display the color from, or let's say display the color detected by the Color Pal on the OLED display. All right. So we'll click Next. We'll make sure we share this project so you can see it, and click Finish. All right, so let's go ahead and turn off our board, start disconnecting some stuff. We're not going to use the ping. We're not going to use the servo. We're going to leave our batteries plugged in though, and we're not going to need the resistor, but we are going to need some wires. The OLED display, let's go ahead and set this up. So if I go to communicate, the first thing I want to point out with the OLED display is that the second block here says OLED font loader. I'm showing this to you because it's kind of an important thing. If you want to display any text on your display, so text actually takes up a little bit of memory because the Propeller actually has to draw each character pixel by pixel, and so each font is sort of a map of what the letters should look like, and we have to load that map to EEPROM. Now, the cool thing about EEPROM is there's some additional storage in here besides just where your program goes. And so what this font loader does is it actually takes and stores the fonts in here on your activity board. You'll only ever have to do this to your activity board once, and then it's always going to be in your EEPROM. But we are going to load those in there so that we can use the big fonts with our screen. Now, if you haven't done this, when you go to OLED and you start wanting to do something like setting your text size to something like medium or large, it will only ever print small if you've not installed these fonts. It'll still display something, but it'll display small text on there. And so what we'll do now is, without anything plugged into our board, we'll turn it on to the one position, and then you only have to just send this to your board. Oop, gotta make sure my board's selected. You just have to send it to RAM. Now what's going to happen is the terminal's going to open up and you'll start seeing the P26 and P27 LEDs blink once this starts loading to the board. It says it's establishing a connection. It starts loading fonts, and the lights will start blinking. Now, you don't want to do anything. Don't disconnect it, don't reset it, don't cut power until both lights turn back off. Because the fonts actually do take up a little bit of memory, this process takes almost a minute to complete. And so we're going to let that run until we see the lights turn back off. So blinking, blinking, blinking. And there they turn back off. So now we can close everything out and the fonts are loaded. Like I said, we only ever have to do that once. So we're going to turn that back off, and now we're going to get to the point where we start connecting our screen and using it. So on the screen, there are a set of pins here. Let's see if I can focus on that a little bit better for you. VCC, ground, NC means no connection, and then data in, clock, chip select, data, or command, and reset. So basically what we have to do is we have to connect actually 7 different wires to the screen to make it work. So we're going to put this here on the end of the screen. Now, if you remember the OLED, the first block here is initialized. That starts it up. Just to help us out, we're actually going to go to Help, just to see. And you'll notice there's a little bit of information about the screen and actually about how the pixels work. It shows you how many pixels there are and where they're, so the top left corner is pixel 0, 0, and then in the bottom left corner is coordinate 95, 63. In the OLED block here, it shows you actually how you can connect it. And so what we'll do is we'll actually mimic that. Might not use all yellow wires just because I have more colors than that. But let's go ahead and plug this in. And you'll notice that, and the cool thing is actually, we're connecting into 3.3 here in the tutorial. It actually doesn't matter if you connect it to 3.3 or 5. It's got its own little power regulator here on the back. But we'll follow the tutorial. And the first pin connected is power. And then the next one connected is ground. And so if you're looking at those, they cross like that. And then now we'll start connecting a few signal wires across. Get those out of the baggie here. Ooh, almost got enough. A couple more. Oh, one more wire. They're getting stuck on me. There we go. Now we've got enough. Okay. So the next pin after power is actually a non-connect, so we don't need to connect that one up. So we'll go to the next one over, and we're going to just start this in, you can pick any really, but I'm going to start in P7 just like the diagram. P7. And then we'll do the next one in P8 and just go down the line until we get 5 wires plugged in here. P7, P8, ooh, almost, P9, P10, and P11. Those are 5 signal wires that we need to make the screen work. All right, so far so good. And from here, the other sensor that I wanted to connect to this is the Color Pal. Now I want to connect it to the header up here, so we'll it's VCC and ground, so sorry, V plus and ground, so ground being the black wire. I'm going to make sure that's the one connected closer to the breadboard. And then we'll grab the Color Pal sensor. And on this, you'll notice that there is, focus that a little bit better. It says WH, that represents the white wire. It's also here on the back too, making sure that we get this connected correctly. So notice I have to flip this around in order to do that. So there we go. Now we're connected. The colors matched up correctly. And the Color Pal's connected and ready to go. And remember, because I plugged it into the header here, that's only going to work if we're battery powered. So I'm going to make sure that I've got my batteries off to the side and plugged into my barrel jack there. And when the switch is in position 2. So go ahead and switch it over there. Now, let's go ahead and create our program for this. So we need an initialize block for the OLED screen. And so we'll remember the first data pin got connected to P7. The nice thing is these are all in order, so you just go down the line. If you connected them in order, you can just tell this block they're in order too. So the next thing we need is if we go to Sensor and Color Pal, that needs to be initialized as well. And we plugged it into the P17 header at the top. All right, so now we have some information. So next, let's go to Control, and we're going to repeat. And actually, before we do that, let's put some text on the screen. So let's go ahead and print on here color pal color. And the next thing we're going to do is we're going to draw a box. So we're going to pick draw rectangle. Now, if you remember from the help for the OLED, the top left corner here is 0, 0. And by default, if I don't tell it otherwise, that's where it's going to start printing text. And when it runs out of room, it'll wrap around. And then the bottom corner here is 9563. And so if I don't want to accidentally draw my rectangle over the text, I ought to start down a little ways. And I'll start in too, just for good measure. And so what I'm going to do is I'm going to draw my rectangle at, let's see, X is across. And so let's just start 10 across. And just to make sure that we've given our text enough room at the top, let's go 20 down. Now, since the screen is 60, it's 95 pixels wide. And if I got 10 on one side, I want 10 on the other. It would need to be 75 wide. Let's go 20 high. So kind of a long rectangle. Roundness would actually round to the corners of the rectangle. And if we leave this at 0, it'll be a pure cornered rectangle. Now for color, we don't want to set it to white. We actually want it to be the color pal's color. So let's get rid of this. And let's go to the color pal sensor. And we're going to get the color. And we're going to detect it and store it in the item variable. So let's actually rename this variable to sensed color. And click OK. And now in my variables, I have sensed color as an option. So now I can click that. We want to make sure the fill box is checked, because otherwise what it'll do is it'll draw an outline of the square. And this will repeat, so it'll sense a color, and it'll then draw a rectangle based on that color. And it'll draw it over the top in the same position. So let's go ahead and run this. So we'll load it, make sure my board is selected, load this to RAM. All right, so far so good. Scroll down here, looks like we're all okay. And if I click on my screen here, it says color pal color. With the bright lights, that might be a little hard to see. Okay, so far so good. It's not detecting anything yet, but let's go ahead and take a red chip down here. Ooh, get some red on the screen. Let me turn off a light and see if that actually shows up a little better on the camera here. If I do that. Oh, there we go. That's much better. So look at that. When I set the color pal on top of the red chip down here, I get that. Now if I do this same thing with the orange one, it looks a little red. The camera doesn't get that color quite right. Let's see if yellow is any better. Camera's not color balanced very well. Green. Oh, there we go. That's something a little more closer approximating. Ooh, so when I'm on white, there we go. There's white. When I'm on this goofy lime green box, let's see if it gets that right. Kinda. So color is one of those interesting things where it's definitely kind of an approximation game, because you always have things like white balance and variations in the amount of, I must have accidentally bumped my power cord there because it came on or reset. You kind of have variations in the amount of red, blue, and green that are displayed by a screen. In fact, if you were to take two of these OLED screens, put them side by side and have them display the same program, you would actually see that one of them might be slightly bluer or redder or more greenish tinted than the other. And those are just kind of natural variations in tolerance from part to part to part. And then the color pal sensor also has some variations in its red, green, and blue detecting diodes. And so there's always going to be kind of an approximation when it comes to sensing color and displaying color accurately. And then everybody's eyes perceive it a little bit differently too. But the cool thing is it oftentimes gets you close enough that you can get things in the ballpark. So we could use this, for instance, as a candy sorter. We could put this over M&Ms and detect, hey, am I over the blue one or am I over the red one? In fact, in in values, we actually have a few color blocks that might be really helpful for you. So we have, we can actually make a color from red, green, or blue. We can actually mix those three together, and the options here. So if I hold over that, gives me a little more detail. I can choose from 0 to 255 for any of these and mix my own color. I can, under values here, I can get just the amount of red, green, or blue from a color. That's also helpful. So you can say, hey, how much red is in that? And under values, I can actually compare two colors. And so if I'm looking for instance, let's go with it. If I'm looking for green M&Ms, I might want to take and see, well, how close is my sensed color to green? And if I hold my mouse over here, it returns a value from 0 to 255, 0 being these are the exact opposite colors to these are identical colors if it gives you a high value of 255. And so you would use this block, and then you would use something like, you could say if, and if I go to numbers here, this is a comparison block. So I could say if my compared colors, starting to stretch out here, are greater than, and so like a really close comparison, if my scale is from 0 to 255, if my compared colors are greater than 200, now I can say, yeah, that's reasonably close to green. And you could do this a few different times. Maybe I could say, hey, I found the green M&M, or I could turn my servo to like line up with the chute where I'm trying to send the green M&Ms down. And so that's an example of how you could use this program to like be a candy sorter. And so all of a sudden you've got a tool that is really easy to use. You've got blocks that you just drag in place and you connect them together and you experiment with it and you have a lot of fun. But it's also surprisingly powerful. You can do real world stuff with this. You can actually build devices that detect things about their environment and then make decisions based on what it detects. And whether, for instance, you could hook a thermometer up to this, and a lot of thermometers output a voltage, so you can actually detect voltage and then say, hey, if it reaches this amount, turn on this transistor, for instance, and then and that maybe closes a flap for a heating system, and so now you can build a thermostat, or you can control a scientific experiment. There's all kinds of things, and the possibilities here really are endless. I'm in love with this kit. I hope that this has been kind of just a nice, helpful introduction to it. Just right out of the bat, you could see we could literally open the box, throw the parts out, start connecting things, start dragging blocks in place, and all of a sudden you have things that just work. It's a lot of fun. It's incredibly powerful. I encourage you all to run out and buy one of these things, and you won't regret doing so, because you're just going to have a lot of fun while you're doing it. You're going to learn a ton too. So again, I'm Matt. I'm from Parallax. If you have any questions, you can email me directly. You can reach out to us through our customer service. If you're an educator, we have a hotline on our website. Ring straight to me. Happy to answer that and talk to you about what we have, or help you troubleshoot a problem you might have with our stuff. So thank you all for hanging out and watching the video.